Hello everyone, so I hope you are all doing well. So let's dive straight into the topic. So today the problem that we are going to solve is merge two sorted arrays. So first of all, let's look at what is the problem. So we have been given two arrays, let's say L1 and L2. The first one is, let's say, 1 5 9, and the next one, let's take it as 1 6 8, and the length of the first array is n and length of the second array is m. So now we have to create a third array, let's say L3, which has the length equal to n plus m, and this elements, all the elements of L1 and L2 should be present in L3, and they should also be sorted. So L1 and L2 are already sorted, and we have to create a third array using L1 and L2 elements, which is sorted. So the output for this will be 1 1 5 6 8 9. So this is the problem. So the naive approach would be to just take a new empty array L3, put all the elements of L1 and L2 in L3, and just apply a sorting algorithm, and we'll get this output. But as we all know, the time complexity for sorting is nlogn. So when the elements become n plus m, the time complexity for this algorithm will become n plus m log of n plus m. So this is a valid solution, but let's see if we can do better. So let's first understand the intuition for the optimal solution. So let's take those two arrays again, 1 5 9 and 1 6 8. So this approach is known as the two pointer approach. So we keep a pointer in the beginning of both the arrays. Let's take it as I and j. We compare the first element. Now the first element for these arrays is equal. So in this case, we can move either of the pointers ahead. So I'll move this pointer ahead, and before moving it ahead, I have to put this element in the new array. So I put 1 here and move the pointer forward. Now I'll compare 5 and 1. So if you see, 1 is smaller, so again we put 1 and we move this pointer forward. Now we'll compare 5 and 6. 5 is smaller, so I'll put 5 in this array and move this pointer forward. Now 6 and 9, 6 is smaller, so I'll put it 6 here and move this pointer forward. Now 9 and 8, 8 is smaller, so I'll put 8 here and move this pointer forward. Now you see here there is nothing, so we have reached the end of the second list. So we'll place all the remaining elements of the first list here, and we get our answer. So this is how the two pointer approach works for merging two sorted lists. So now let us see how we can implement this in code. So as you can see, we have the main function here, which will create the output. So we have been given two vectors, L1 and L2, which will be sorted arrays. Vectors are nothing but dynamic arrays. So for this video, we'll consider vectors equivalent to arrays. So first of all, we remove the length of both the arrays in n1, n and m, and then we initialize two pointers, I and j. I is for the L1 vector and j is for L2 vector. And now we create a vector L3 in which we will store our output. That is the final sorted list that we want. Now, as soon as we enter the while loop, we'll check if the ith value in L1 vector is less than or equal to the jth value in L2 vector. And if it is less than or equal to, then we'll push it in L3. And if it is not, then we'll push the jth value of L2. This is just as we had discussed in the intuition. And once we reach the end of either of the arrays, the while condition, that is I less than n and j less than m, will become false and will break out of this while loop. Now we'll use these two while loops to push the remaining elements of the other array. So let's say in this case we saw that we reach the end of L2 array, but still there is 9 element remaining in the L1 array. So for that we have wrote these loops so that the remaining elements get pushed in the L3 vector, and then finally we return the L3 vector. So now let's just run this for this input and see what we get as output. Okay, so you can see we have gotten the right output 115689. So that was all about today's video. Thank you so much everyone.